Hello everybody, we're taking a look at some review from yesterday, and it starts off by talking about how can we create a triangle. Well, in order to create a triangle, we need to have the two smallest side lengths be greater than the longest side length. So if we look at this example here, we take the two small side lengths, 3 and 10, and when we add them together, we get 13. 13 needs to be greater than our longest side length, which is 11. And that is true. 13 is greater than 11, so that forms a triangle. Look at our next problem here. We have the two small side lengths of 5 and 7. And so when we add those together, they need to be greater than the length of our longest side, which here is 15. So is 5 plus 7 going to be greater than 15? Well, that's going to give us 12, and 12 is not greater than 15. So no, this is not going to create a triangle, and we see there's a big gap there between the two sides. Now we move over to the type of triangles that are created when we look at our side lengths, and it's all about squaring our side lengths. So we look at our chart that we created yesterday, 9.2.1C resource page, and we talk about if we have the square area of two side lengths that are greater than the square area of our longest side length, it'll create an acute triangle. All right. For example, let's say x is 6, y is 7, and z is 8. Well, 6 squared plus 7 squared needs to be greater than 8 squared. Let's see what happens here. 36 plus 49, is that going to be greater than 64? Oh yeah, that's definitely going to be greater than 64. So yes, that creates an acute triangle. Let's look at the next one here. We've got P, Q, and R. Let's say P is 2, Q is 5, and R is 6. This time for an obtuse triangle, these two smaller sides need to have the sum of the areas to be less than the area of the longest side. So we're going to do 2 squared plus 5 squared needs to be less than 6 squared. Is this going to be the case? 4 plus 25, is that going to be less than 36? You bet. That's going to give us 29, and that is in fact less than 36. All right, good deal. So this is obtuse. And then we have a right triangle. This is the one we're going to be working with a ton today and for the rest of this unit. So as far as a right triangle goes, and these are seen everywhere in everyday life, we're going to go ahead and take the smallest side. Let's say it's 3. We're going to take the second smallest side, which we'll say is 4, and it has to equal the area of the third side length, the longest side length. So here we take 3 squared plus 4 squared. It has to equal 5 squared. Let's go ahead and try it out. 3 squared is going to give us 9 plus 4 squared, 16. Does that equal 25? Let's see, 9 plus 16 equals 25. 25 equals 25. So yes, this would be an example of a right triangle. All right. So if we're going to go ahead and take a look at this problem here where it says A is 3 and B is 4, and it creates a right triangle, well, what would C have to be? And think about this in terms of A squared would be 9, B squared would be 16. So then what would C squared have to equal? All right, and then what could you do with your answer to figure out what C is? This is a little bonus question for you. Gets you thinking. All right, so we talked about the math notes here, and this is going to help us dive right into the Pythagorean theorem and right angles. All right, so looking at right triangles today, let's get started.